Let's continue writing this verify thing. Verify is actually more or less the same as what we just met, but let's write it anyway. It should be called ModifyMana. Let's just go with ModifyMana. How do we simulate this actual logic? That is, I need to determine the value of this mana. It should be greater than 0. But here, I write a ModifyMana value. Then in this ModifyMana place, we return an intersensor. This method will change is ModifyMana. That is, for this mana, every time it is called, we will reduce the mana. Let's give it a value of 50. Format the code like this. Then format 50. Then put it here. We make it subtract equals 20. Then return this value. Then modify again. Then at the ModifyMana place, we use this code. So here, it's obvious that I need to call this ModifyMana thing. This ModifyMana, it should be greater than 0. Okay. If it is not greater than 0, it proves that our logic is problematic. If its ModifyMana is greater than 0, we can then execute. For example, execute attack magic. Operations like tool magic. Then we might have a setting that our mana value is our health value. Mana can never reach 0. Now let's code this interface just to see the effect. Okay, then we're still here. We'll still use this. Still use it. Then we take 1. Modify. It should be called mana. ModifyMana, that is to say, go. Educate this mana. Save it. We press E. The first, second, and third times all had issues. You see, this method is another assertion problem. But it executes every time. You can see, but it won't crash your code or program. It can continue running. Look, let's look at this battle. You see, function, then execute here. At this moment, it means there was a problem when executing this function. Here. Okay. You see, it just executes up to this point. The problem is right here. It can't move. It's stuck. Okay, let's stop here. This is how verified is used. Next, let's look at the following ensure. When we use ensure, sometimes we want to check some information, but we also want the log to be available. Then we can use this thing called ensureified. Let's write it here. For example, we have one here, ensure vision. We check this version, right or not. Then here, let's keep it simple. We just pass a bool. We just, whether it is a vision for this version, whether it is correct, we give a bool. That's it. Okay, then here, we just do it like this. We just copy and modify this code a bit, if our version is correct. We can just print a log here. We directly write that the current version is incorrect, but sometimes it is incorrect. We can still run it. This is how I wrote this HTTP client earlier. When I was working on that server, we provided a login plugin for everyone at that time. And then we implemented a version check. Actually, if we had written 2.5 at that time, 2.6, 2.7, actually 2.5, 2.6, 2.7, only the client plugin changed. The server interface did not change. So in fact, the 2.6 server can fully connect to the 2.6 and 2.7 client, right? That's fine now. In other words, this thing is harmless, but we hope to fix it in the future. So you can do it this way. Of course, you can also fill in a parameter here. We don't need to fill in this parameter here because it must also be similar to this. The way of filling with variable parameters. Okay, then here, if the version is correct, we write a log here. Let's see if there is a log earlier. Let's call one over. Okay, let's write version correct here for everyone. Now let's call it. Then we can check if our log is output. Just now the version was incorrect. If we pass a force, our site is relatively flat and the content is also relatively simple. We didn't restrict this. Compilation time. Actually, using live queue should be fine. Shouldn't be a big problem. We have a share revision. Okay, alright. Let's first make sure the version is correct here. Press 1. Let's observe the log. Hey, version correct. Then if we think the current version is incorrect, actually, this requires comparing a version. We need to put the current version in an NI file, or encrypt it yourself. Put it in a save slot when saving. Then verify it during runtime. Hey, assertion at a location. Right, we can see now it doesn't crash, and it has a ensure condition fail behavior, and then blah blah blah. It is at a certain location. Then finally it printed that this assertion is incorrect. Then if you press it again, it won't respond. It only executes the first time. Okay, so this version is incorrect. Such a judgment. Then let's look at two more. One is this. That is a relatively heavy check. Low entry. That is, this should not happen. This one is a bit more complex for now because it still has some. This application is actually quite common. Then we might need to write an enum. Write an enum like this for everyone to see. Everyone still remembers how to write an enum, right? Blue point. Type should be this. Sometimes, if you type it wrong, just copy it. An enum actually has several methods. I'm not sure if everyone has been taught. An enum can actually put the original data later learn, that is to say, sometimes we have a scenario like this. I'll finish writing it for everyone today. TRP. We need to use English shades to reflect blueprint. For example, there's a loan somewhere, and we won't write its original data here. Loan, or we left. Actually, sometimes we can get it and convert it to this value. But you need to pay attention to this metadata. This UMeta might cause issues after packaging. There is a small detail here to share with you. There is a display lang record here. For this display lang, after you package it, there might be a slight problem. That is, it might still retrieve the previous key value rather than the commented value after it. So for now, let's ignore it. Let's not use this for now. This is not what we are going to cover. Then it can use reflection to retrieve some information inside through reflection. That is, you can use statue to convert it into a string, but you can also write a method that takes an enum and outputs a string most of the time. We might choose the second method, but sometimes when we have many enums and we don't want to write it that way, then we hope to use reflection to convert the enum directly for use in Blueprint or in C++. We will also demonstrate this later in the HTTP server. So this spot is just right for viewing. Just a quick mention for everyone. Okay, so here we will write the method. As for this method, we will name it checkNoEntry. That is a method that does not allow breakpoints. Such a method. Then we use an enum to control it. As for such an enum, we can directly use it as a parameter. Actually, when it comes to enum in our coding standards, there might be some older ways of writing enums. they might not be very elegant. It may not be possible to directly use this enum as a parameter. This place, there is a small detail. Sometimes when you want to enumerate and reflect, it might not work. Interesting, because its enumeration is a kind of older declaration. That is an older version of a declaration. Okay, here we can directly switch. And this idea here, the idea actually has a very convenient mechanism like this. When you write it for the first time, you can do it like this. See? Let me show you again. First, you type switch. Yes, then paste this enumeration over. Oop, pasted wrong. Sorry, paste it over. Then press the down arrow. Hey, it just came out. It's roughly like this. And pay attention to this break. Don't miss this break. Otherwise, there will be problems. And actually, we'll just switch directly to the design. We won't worry about the rest. And don't do it this way. Don't declare variables here. There will be problems. You can see a equals 1. No. It's a It's not even a word. Don't declare it like that anymore. Doing it this way will cause problems. You can see it will actually have problems. That is to say, don't do it this way. You can do it this way. It's fine. Write it like this, enclosing it in curly braces. Doing it this way is fine. It will compile successfully. These are some small details. Since we happen to cover it, it seems we haven't explained to everyone the for loop and if these things. Right? I didn't explain this to everyone. I think there's no need to explain this. This should not be simple. And if you need it, you need to use it externally. For example, fstring. Fstring message. You do it like this. For example, here. That long okay. And then here, do an assignment. For example, here it equals this. Okay. And then here it equals medium. First, the wrong position. Okay, good. So you can normally use this message here because it performs a branching operation based on each statement. This is actually a small trick in practical development. Why do we say that? Some relatively inexperienced programmers, they just use if else, if else, if else, if else. But when there are many cases, you can use switch. That's the situation. But an if else is also perfectly fine. It's just a way of implementation, a way of readability. See which one is more suitable. Then here, we call this is called checkNoEntry. Okay, let's test his. Then let's not try this for now. Okay, let's not try it for now, because this will crash. We don't want to open the editor again. It's quite troublesome. There seems to be a breakpoint here. Let's just ignore it. Please let us return it. My side is relatively simple. Let's just ignore it. You see, there's absolutely no problem here. When we press 1, actually that message, he changed it to that. We can have him reply. But it seems relatively simple, not really necessary either. In this place, we use this alone. You can see it crashed, right? Then take a look at our call stack. Get used to reading the call stack. Get used to looking at the call stack. This place seems... Anyway, it's line 71. Line 71 is right here. It crashed here because this place is not allowed to enter. Okay, then let's continue with the following content. Sometimes, actually, when what you write is a bit more meaty, a bit more, we can write another one. Let's just finish writing it. Let's just finish writing it all at once. It's just the last little bit. We need to switch to code. We don't need to go to this place anymore. No need to pass parameters, because then we switch to slow down. Okay. Very simple. You see, here in checkCode, we might need to execute a series of this code. So let's just do it here in checkCode. Okay, here we can write a function. Take a look at this checkCode. Actually, check if the engine is using it. You see, the engine also uses a lot of checkCode. Such a parameter. And then it wraps another check inside. It just means there will be execution here. But it doesn't seem to define a return value. Yes. We'll just have it pass a Boolean value here. Let's call the Boolean be in alright. This way we can simulate that function. We'll put this here. Okay, here we can just print a log. Let's copy a log monster. For this log, we'll call it everything normal. Then here we add an else. If it's not the case, it means there's a problem. Then you might need to check here. For example, check. Just use checkFalse directly. That proves something went wrong and it's not normal. Let's not comment it out for now. Let's comment it out first. Check if the code here will cause any crashes or anything. Okay, let's instantiate here. And here we change the function signature. So we'll also add a function signature here. Then let's add a function signature here too. Let's just write it all together. Okay, and here, let's modify it. Then this, maybe we are dvlgam. We can change it to dvlm. We can see if it will clear itself. We write it in Chinese. It seems to be showing red. If it's showing red, maybe we don't have this thing. We just want to check whether the engine iteration is missing. It should not have this F. Maybe there is an extra F. Let's just ignore it. Okay. Let's test these two functions. Now let's switch it to development editor mode. If you don't have this editor, it will actually only output the game. That is, there is no editor. Yeah, this should have been mentioned to everyone before. Everyone, please recompile this part. So we'll just cut out this period. It seems there is no message after cutting the slow here. No message. Let's delete the message. It should be fine now. Okay, let's launch it now. Then we should be done with the lecture for this lesson. In the next lesson, we will simulate a crash of the packaging and read the dump file. This is one of our ultimate debugging methods. Most problems can be well resolved at this step. Oh, okay, we are still here. Let's find it. Let's peel it off a bit. This place should be check. No code. Let's first make everything run normally. Actually, it shouldn't affect anything. Everything is normal. Then we execute this one. Then pass a force. So this place, you can see everything is abnormal. And actually here you need to add a check here. Okay. Then now we go execute these checks now. Checks now for. Let's first make everything normal. It should have no reaction at all. Now let's make it everything abnormal, then we execute again. Actually, I expected it should also have no reaction. See? Hey, it actually has no reaction, right? You clearly posit a fault. It has no reaction. Why? Because it is slow, so it is not present under development. So let me demonstrate again. We switch it to debug editor mode. Let's check if it's there. Okay, I'll just cut it off here. We are now inside. We are now in debug mode. Now let's make everything abnormal. Let's take a look. Take a look. It seems this part didn't execute. Let's check the second breakpoint. In all right. Hey, it seems the second breakpoint can't be hit for some reason. Let me check again. Snow off. So it might be that this breakpoint won't be hit. You'll notice that our side actually didn't hit it, right? This square, you see we already have debug. but it still didn't hit this point. But if we use another method, it actually works. In this case, then it proves it might be related to this debugging, this slow reason. It might be related to our debug mode. Then let's just ignore it. Basically, you only need to use this ensure and this check. It's best not to use the others. It's better to make judgments through log. These methods. Okay, we'll stop here for this lesson. As for assertions overall, I've spent about an hour with you going through it. The content of this chapter is still relatively simple. Thank you, everyone.